All right, I'm just going to go over, just as a little supplement, how we get the integrated rate laws. Using calculus. All right, so this is where calculus comes in, that word, integration. So let's talk about some general reaction, A going to B. And we know if we were to graph the concentration of A over time, if we have a zero order rate law that is basically constant rate, no matter what the concentration, you're going to see this kind of a graph. Okay, the amount of A is going to go down over time and in a very constant way. It doesn't matter how much you have. So if we talk about the rate of this reaction in terms of A, we say it's the change in the concentration of A over the change in time. But this number is negative, and when we talk about how fast the reaction is going, because this number is negative, we might just want to multiply it by -1 to make the rate a positive number. Okay? Now, if you take a look, there is this little delta, and what we want to do is we want to just change this to use some of the terms that you use in calculus. If we have a very small change in concentration and a very small change in time, instead of using that delta, we're going to use this letter D, like derivative, very small change. So if we were to write this rate law again, all right, you would write it like this. But if we wanted to make the rate just a general rate of reaction, we would multiply this by -1. But if we're using calculus, we're going to do this. We're going to say -1 times dA, or calculus abbreviations. We're going to do that. So what I'm going to do is I'm going to rearrange this equation a little bit. So a very small change in A is equal to -k times a very small change in the time. So if I go ahead and I integrate this, so this is where we get fancy, from a time 0 to a certain time t, what you will get is the following. The concentration of A at time t, the final concentration, minus the initial concentration is equal to -kt, and this t being basically the final time minus time 0. And this is your IRL for a zero order rate law.